Yeah. I'm sorry. We'll talk about it in a second. Okay, so you should be on third from the bottom. Okay, you should have the differential equation that's on the screen. Oh, I said fifth. Sorry, I'll do fifth. It doesn't matter. We're gonna do both. Okay, so fifth would be this one. Is this right?
Yes.
Okay. All right. So we're gonna work 2 questions off this homework. We're gonna do the fifth from the bottom first, then third from the bottom we'll do second. Okay, so dy dx equals. Go ahead and write down your equation. So it's e to the x minus 3 times y cubed. So the very first step for you to solve this is going to be to separate. So if my y cubed is multiplied on this side, how am I going to get it to the other side? Divide it. So when I divide it, it's going to be a 1 over y cubed. Okay, so slash it out. Okay, then I also notice that I have a dx that's on the bottom on the left-hand side, but because that's an x, we're going to multiply it across to the right-hand side. So you should now have this 1 over y cubed dy e to the x minus 3 dx. Okay, next step. What do we do to both sides? Nope. Integral or antiderivative. So we have to get rid of the dx and dy by doing the antiderivative. Okay, and so let's go ahead and do the e side first. What is the integral of e to the x? So what's the integral of e to the x minus 3? Okay, plus c. Very good. Okay, on the other side, this is not an ln. Here's why. 1 over y, that's an ln. 1 over y with a power, we're going to have to rewrite. How can I pull this y cubed up so that I can do power rule on it? Very good. So I'm going to rewrite the left-hand side of this as the integral of y to the minus 3. And if you want to put RW for rewrite. Okay, then I'm going to add 1 to that. What is the new power if I add 1 to negative 3? Negative 2. And then if I have to divide by negative 2, I'm going to put a minus 1/2 in the front. Okay, but however you want to think about that, basically when you add the 1 to get the negative 2, you have to divide by that to the front. Now remember, we want this y to be by itself. So if I have a divide by negative 2 in the front, how can I undo that? Multiply by negative 2. And remember, technically, we need to do the whole equation by that. So my negative 1/2 is gone. Now this is a negative 2e to the x minus 3. And then what happens to the c? We keep it a plus c. Because remember, you already didn't know what the c was. So if I double it, turn it negative, it's still unknown at this point. Okay, for your next step, y to the negative 2 is the same as 1 over y squared. Okay, so I want you to rewrite that for now. So if it's a negative on the y, that means really that belongs in the bottom. And so when you were in algebra 2, okay, you should have done a whole unit on solving rational equations. That's basically where your y is on the bottom. If my y is on the bottom here, as long as I do it to both sides, it's allowed, right? So I'm going to flip this side to let my y squared be on the top. But then I'm going to have to flip this side. And if there's nothing on the bottom, what can I always put on the bottom? A 1. So I'm going to put this on the bottom as a 1. so that now I can essentially just flip both sides. So my 1 over y squared is now just a y squared. And this is now a 1 over, and then all the crap that was already over there. So that's what we have so far. And then if you want to make a little note, we're going to reciprocal both sides. Okay, from there, what would we do to get rid of the squared? The root. And when you square root a fraction, okay, remember, you're just square rooting the top and the bottom. Now, thankfully for us, the top is a 1. What happens when I square root a 1? It's going to stay a 1. Okay, so I have y equals 1 over plus or minus the square root of negative 2 ex minus 3 plus c. Okay, that would be your general solution. How do I turn it into a particular solution? Plug in the values to find what? Very good. We need to find what your c is. So it says right there that my y of 3 is a 2. So that means that when I plug in 3 as my x value here, okay, my answer on the other side should come out to be a 2. So let's do that. I'm going to have 2 equals 1 over plus or minus square root negative 2e, and then where my x is, now that's a 3 minus 3 on the e. And then what is 3 minus 3? 0, and what's e to the 0? 1, which means that really, this is just a 1 times a negative 2, which is just a negative 2. So here's what we have so far. 2 equals 1 over plus or minus square root negative 2 plus c. Okay, from there, we're going to pick the plus or the minus before we square both sides. So if I'm trying to match a 2 on this side, then which one do I want to pick? The plus. Okay, then from there, I have 2 equals 1 over, and then positive square root negative 2 plus c. Okay, how do I get rid of the square root? Square. And remember, when you square both sides, fractions, you just square the top and the bottom like separately. So if my top is a 1 and I square it, it's going to stay a 1. Okay, but then on the bottom, that's going to eliminate this square root, leaving me just with the negative 2 plus c. On the other side, we had a 2, square it, what do you get? 4. Okay, then from here, I notice my c is on the bottom of a fraction. So remember that flip both sides step, that's allowed. So if I want to flip this to be a negative 2 plus c, then I just have to remember to flip the 4 too. And if there's nothing on the bottom, I'll make it over 1 so I have something to flip it with. And then from there, what's my last step? Plus the 2 across. So if this is a 4th, that's basically like, think like money, like 25 cents, right? Then if I add 2 across, I'd get 2.25 for my C. So now let's type in your answer. Go to your keyboard. You're going to do 1 over. Okay, then positive square root. Obviously, you don't have to put the positive, but we know it is positive. Okay, then we want a negative 2. E to the power of x minus 3. And then our C was a plus 2.25. You do it just like that. Okay, make sure that your 2.25 ends up inside the square root. Okay, and then that would be your answer. Okay, so I'll zoom in on it if you need to see that. Now, before we move on, you'll notice, okay, Delta Math has a lot of things in it that are great. But do you see that their answer and our answer are not really the same? Okay, this is still right. But to me, the process they go through to solve this looks way worse than what we did. So if you see the green check, you did it right. They might do it in some kind of weird way, but I would not sweat that. Good? Okay, go down 2 questions. We're gonna do one more before we hit our notes for today. Hit the one up there, Lamic. What'd you miss on it? Is your 225 in the square root?
Yeah.
The way you typed it in?
Put it negative 2 instead of plus 2. The negative.
It is a negative 2. And then it should be x minus 3 on top? Yeah. That's okay. I'll count it right. Just remind me when we're finished. All right, next question. 2 below that. Go ahead and write it down. Separate for me. Okay, write it down and separate. I can put it back on for you. So it's dy dx equals 5y over x squared. Okay, we got to separate. What are we pulling to the left? Okay, I'm going to pull the y. Here's why I'm not going to take the 5. If I leave the 5 here, remember 5 is a number. It can go with the x side or the y side. But if I move the 5 to this side, it's a 1/5. And so since I don't really like fractions that much, I'm going to leave the 5 on this side. It'll partner with the x this time. Okay, then my dx, I'm going to cross that out and move it over. So here's what we have so far. 1 over y dy, 5 over x squared dx, then integral. Which side will I rewrite? The y side or the x side? Not the y side. The y side's already special. What's the integral of 1 over y? ln y. Do you remember that? Okay, this is a special rule. I don't have to rewrite. If it's 1 over y or 1 over x, it's going to go to ln. But what about if it's over x squared? That would be a rewrite. I'll use a negative in the exponent. Okay, so for this side, I'm going to RW. This is really 5x to the minus 2. Okay, I'm going to have to pull this one up because it's not just a 5 over x that would bring me to ln. It's a 5 over x squared. So add 1 to your power. Negative 2 plus 1 is what? Negative 1. So it'd be x to the negative 1. And then what do I do with my negative 1? I add it and then I divide it on the 5. So what is 5 divided by negative 1? Negative 5 plus b. Now, at this point, before you keep solving, if you have an x with a minus 1, where does that x really belong? On the bottom. So before I keep solving, I'm going to make it a negative 5 over x plus c. Okay, even though these are really the same, okay, I think it'll be easier to solve it without the negative exponent. How do I undo this ln on my y? E both sides. E and ln are going to cross out. So I have y equals e to the negative 5 over x plus c. And all of this crap is now in the exponent. The c is little too. It's part of the exponent as well. Okay, to get rid of absolute value bars, okay, you just apply a plus or minus, just like you do on a square root. So I crossed out my bars and I put a plus minus here. That's how you get rid of square roots, and that's how you get rid of absolute values. Okay, now look at your point. What is my answer going to be when I plug in negative 1? E squared. Very good. So I'm going to have e squared equals. And if I want to match the sign on the e squared, am I going to pick the plus or the minus for the front? Plus. So I'm not even going to, well, I guess I'll put it, but it'd be plus e to the negative 5 over, what's my x? Negative 1, and then plus c. Okay, what is negative 5 divided by negative 1? So that's e squared equals e to the 5 plus c. And then we're almost done. If they both have an E, I can just cross it out. But what algebraically am I doing that crosses those E's out? You're ln'ing both sides, but either way, both of your E's are going to be gone. So now I have 2 equals 5 plus C, last step. Subtracts the 5 across, what would my C be? -3. Very good. Okay, so in your calculator, or sorry, in your computer, you're going to type this guy in right here. Okay, but you're going to change this C out to a -3. Now, for the plus or minus in the front, remember that we chose the positive. You wouldn't have to put the plus, but it would go there. So -5 over x minus 3. Okay, just like that. E to the -5 over x, and then your C is a minus. Okay. So do we kind of understand how to do the level 2s that when you have time to work on it later, you can do it? All right. So that being said, okay, let's switch to your notes for today. Okay, we're going to talk about proportional differential equations. Okay, and as you can see, we really are only going to do like 3 examples of this because this is a heavier topic on AP, but I didn't give you a new delta math. There is no new delta math. All right. Okay, so circle the word proportional. Okay, if I tell you that 2 triangles are proportional, okay, from geometry, you should have learned that basically what that means is all the sides are either growing or shrinking by the same ratio. So proportional means that there is a constant ratio. Okay, you may remember in geometry setting up proportions. Okay, so essentially what that means is that everything is scaled the same. Either everything doubles, or everything cuts into half, or everything times is by 3. Okay, that's what proportional means. So if you have 2 quantities that are proportional, okay, that constant ratio is going to be called K. So we're going to write a couple rates before we actually solve anything. So go ahead and read this first. It says, if the gallons of gas consumed by a car is proportional to the number of miles, you would say that your gallons of gas is equal to Kn. Okay, because my gallons of gas, it says, is proportional. That means that it's K times something. K times what? The number of miles N. Okay, read number 2. This time it says the rate of change of area. Now, A would be area. How would I say rate of change of area? D, D-A-D-T. Okay, so the rate of change of area. Then it says it's proportional to, so K times something. And then K times what? We're proportional to the square root of the side. So that'd be root S. Next one says the rate of change of population. Well, if population is P, what would the rate of change of it be called? dP/dt. And then it says it's proportional to what? Cube of the population. So we'll say P, or population cubed. Okay, last one says water leaks out of a barrel at a rate proportional to the square root of the water remaining. So if W is water, what would we call the rate the water's leaking? D W dt. Oops, and then I forgot to write what should be here. I forgot the K. Remember, K comes from the proportional relationship. So go ahead and squeeze a K in there. Okay, and then for this last one, it says we're proportional to what? The square root of the water. So it'd be K times root W. All right, so that being said, this is an AP free response question. Read through it, and I want you to see which of those correctly models what they're describing. So it says a rumor spreads among a population of N people at a rate proportional to the product of the number of people who have heard the rumor and the people who have not heard the rumor. P is the number of people who have heard it. Which of the following differential equations could model this situation with respect to time? Okay, so let's kind of break down. The number of people that have heard the rumor is what letter? P is who has heard it, and we want to talk about the rate that they're hearing it at. So what would I call the rate of the number of people who have heard the rumor? D? dPdt. Now look, every single answer already has that part right. Okay, so dPdt equals, then it says it's proportional, so put your constant K. And then it says it's proportional to a what? Products means what operation? Plus, minus, times, or divide. Product is multiplication. So I'm going to do this times this. Okay, we know it's a product. That means two things are going to be multiplied together. Then it says the people who have heard it and the people who have not heard it. So we'll put, these are the people check that heard it, and this is the people X that have not heard it. Okay, what letter stands for the people that did hear it? D. And how would I find how many people have not heard it? Yeah, I'd take N, which is all the people, and I'd minus out the ones that did not hear. Okay, so just kind of think about if that makes sense. K is your proportionality constant, and then you do the product of they heard it, and this is everybody else left over. So what answer would we want? B. Okay, now let's get into actually solving. So take a look at number 5. Okay, it says a population in a hive of bald-faced hornets is growing at a rate, that would be dPdt, because this is how fast the population of hornets is growing. And what is it proportional to? The population. So we'll put KP. Now, in this case, my P's are like my Y's, and my T's are like my X's. So if I want to separate this, where is this multiplied by P going to end up if I have to move it that way? It's multiplied here. Where will it end up when I move it? Divided on the bottom. So put 1 over P dP. And then my dt is going to have to move this way. So it would be K dt. Good so far? So all we did so far is separate. Next, we're going to do what? Starts with an I. Integral on both sides. And 1 over P is special. What is the integral of 1 over P called? ln. Okay, remember that K is a constant, and my variable of integration is dt. So on this side, if I'm integrating a constant, even if it's a constant I don't know, with respect to time, what would the antiderivative be? So like if it was a 3, it would go to 3t, right? So if it's a k, what would k go to? K to t. And you would basically just give it its t back because you're taking an antiderivative. K then plus c. Next step, remember, I want that p by itself. How do I undo the ln? E both sides just like we did on the notes. So I have p equals e to the kt plus c. Okay, now we're going to do something a little weird that you're not going to do on the Delta Maths. Okay, on the AP test, you'll do it, but not on Delta Math, or it'll make your answers harder. Okay, at this point, there's a special rule that if you have e to the kt plus c, that is the same as e to the kt times e to the c. And you should kind of recognize this rule that if I'm multiplying things with the same base, really I would just add the top numbers. So we're using that same property to separate. And now here's where it's a little bit weird. Remember how we don't know what C is? Okay, it's a number, but we don't know what it is. Well, then e to that power is essentially still a number that we don't know. So we're going to call this a new constant and just combine them together. So your general equation is going to be CE to the K. And then you should have used this equation in algebra 2, and I think even again in pre-cal, that this is your population formula, basically. Do you remember? It was PE to the RT though, but it's basically the same thing. Okay, now one question that I do want to answer is what happens to the absolute value bars? Do you remember how we can cross those out and put a plus minus? But if C is a number you don't know, then it already could be plus or minus. So typically, if you're going to drop your C down to the front, okay, you would not also put plus minus because any unknown number could already be either one of those options to begin with. Okay? So here's your general solution. It's P equals CE to the KT. All right, now let's read the particulars so that we can find our missing constants. So it says on May 1st, there were 10 hornets. So we'll say at the beginning, there were 10 hornets. So time, comma, population. Okay, then it says in 30 days, how many hornets were there? So that'd be 30, comma, 50. Okay, and we're going to use those two ordered pairs to solve for the two missing constants. We're missing the C and the K. You're going to find the C first using this guy. So at time 0, I should have 10 hornets. Well, then 10 equals CE to the K times 0. What's K times 0? So 10 equals CE to the 0, but then what's E to the 0? Which means really my 10 is C. Now, when you covered this in algebra 2, your teacher probably told you that whatever this number is in the front, that's the original amount. Okay, so that hasn't changed. It would be 10. So your equation is now this. P equals 10e to the k. What's our second ordered pair? 30, comma 50. So 50 is the size of the population when my time is 30. And then we're going to solve for K. This is why I had you pick up a calculator. Okay, what would I do first? I'm trying to solve for K. Yep. Divide the 10 out of the way. What is 50 divided by 10? So I have 5 equals E. And then if it's K times 30, we're really just going to call that 30K. How do I get rid of the E? ln on both sides or natural log. So I have the ln of 5 is 30K. Last step, what would I need to do? Divide by 30. Okay, when you type that in, make sure you don't do it like this. Okay, when you do your ln of 5, you can't divide by 30 right away. Okay, that is wrong. What do I need to put before the divide by 30? The parentheses, good. So it'd be ln of 5 and then divide 30. Okay, that one is correct. Thank you. Got it. So it'd be 0.05. And now that I know what my P is, I have a model that I can use to answer the question they asked. So they want to know how many hornets will there be after 45 days? Then what do I need to do with the 45? Well, multiply it where? There's no 45 is days, so where would I plug that into? The T. So in your calculator, just plug in a 45 where the T goes. So it would be like this. You'd have 10e to the power of, and then this number times 45. Okay, and I got 111.8, which is approximately 112 hornets. Now, if you didn't copy paste the number, I think your answer comes out maybe one smaller. That's fine. Okay, on the AP test, if that happens, they'll account for either answer. Does that make sense? Okay. Let's do one more of those. So turn over to number 5 on the back side, the bottom question. They are, well, the second one's almost the same. So it'll be easy. Okay. All right, look at the next one. Okay, this time we have the radioactive material present in a sample decreases at a rate that is proportional to the size of the sample. So if I have the rate the sample is changing, I would call that ds dt. And then it says it's proportional, that's my K. Proportional to what? Sample size S. Okay, from there, I want to separate. My multiply S is going to end up as a what on the other side? A 1 over S ds, and then a K dt. Then I integral on both sides. 1 over S goes back to what? ln S. My K will go to a K T. I'll give it its T back because it's an antiderivative, and then plus C. What do I do next after the ln? Okay, E both sides. So I have absolute value S is E to the K T plus C. But then remember, okay, I can drop that C to the front and it'll take care of the absolute value bars for me. So my S is C E to the K T. Okay, and then I'll just tell you, no matter what letters they pick, if it starts like this, it ends like this. So you can kind of shortcut to it if you recognize it. Okay, from there, it says they're using 1,200 years for its half-life. Okay, so in science, y'all should have covered half-lives. What does a half-life mean? Thank you.
How long radiation takes?
Perfect. How long it takes to decay to what amount? Half. It's a half-life. So at 0, we're going to have to construct our own points because they didn't tell us how much of the sample there is. So we're going to say that at time 0, I have 100% of the sample. And then after 1,200 years, what percent of the sample will I have? 50, because it's a half-life. Okay, so if it gives you a percentage, you would say, oh, well, then if I start with 100% in this amount of time, now I'm going to have 50%. Okay, let's find our C first. Which point should we use? The one with the 0 or the one with the 1,200? 0. So it'd be sample size is 100% equals CE to the K times 0. But then we know that K times 0 is just 0 and E to the 0 is what? So C times 1, which means my C is 100. Okay, but remember what we said. We already observed that my C is the initial amount. So if I started with 100%, it makes sense that that goes there. So I have sample size equals 100 E to the KT. What is the next ordered pair that I'm going to use? The 1,200, comma 50. Where 50 is the amount of sample size I have left. And then I'm plugging in 1,200. And then we should know how to solve this because the steps are basically the same as the one we just did. How do I knock out the 100 from the front? Divide it. In your calculator, what is 50 divided by 100? Okay, I'm gonna put 0.5, but a half is the same. Then I have e to the power of k times 1200 is 1200k. What would my next step be? ln. So I have the ln of 0.5 equals 1200k. And then last step after that, divide the 1200. In your calculator, can you tell me what that number is? Okay, it will have an e in it, so go ahead and that's correct when you get it. ln of 0.5 divided by 1200. 5.776 e to the negative 4. Okay, do we know what this means? Well, sometimes it's a big number. Yeah, if it's a negative 4, that means you need to bump the decimal instead of backwards to make the number bigger. You actually want to bump it this way. So I'm going to take my point here and I'm going to move it forward 4 times. So the first time it's going to go in front of the 5. And then 1, 2, 3, I'm going to have to put 0.0005776. Okay, now, before we keep solving, your k came out negative versus in the Hornet problem, the k came out positive. What's the difference in what's happening in both things? Okay, this is radioactive decay versus the Hornet population was growing. So if you want to fill in right here, if your k is bigger than 0, it's growth. And if your k is negative, it's decay. All right, so we have our model. S equals 100e to the negative 0.0005776 t. And then from there, they say find the age of a sample where 10% has decayed. Question, should I put a 10% for my sample size? No, if I want 10% to decay, how much of this sample do I want present? 90. Does that make sense? Because if I want 10% to be gone, I need this to be a 90 and then you would solve. So it'd be 90 equals 100e. I'm just going to put blah, blah, blah t because I don't want to write that number again. And then from there, let's solve the rest in the calculator. What number should you type in first? 90 divided by 100. 90 divided by 100 is 0.9. Okay, how do I get rid of the e? ln both sides. So I have ln of 0.9. This is gone. I have the number times t. And then how do I get rid of the number? Divide it. Okay, but then remember in your calculator, oh, I took my number out. You can just copy paste it. So is the ln of 0.5 divide by 1200. And then it'd be ln of 0.9 divide by, and then that number. So I got 182.404. Okay. But really, you would only drop the C down like that on the AP test. Don't do it on Delta Math. Okay? All right. So it's 2 o'clock. You have 45 minutes. Okay, here's what I want you to prioritize. Try the level 2. And then if you go into your slope fields homework from last time, I just took off the questions where you had to make it. A lot of kids in first period couldn't get the little lines going the right way, so I just deleted them. Okay, I know it was the worst thing ever and we couldn't fix it. So your homework for that question, all the make your owns are gone. Okay. Good job. Yes.